Metal Gear Solid 4 is a game that contains many gameplay systems which work together, one of which is called Octocamo. This mechanic is an extension of the camouflage mechanic from MGS4, but this time, your camouflage automatically detects nearby surfaces and applies their textures to Snake's clothing. In this video, we'll see how you can read texture data from a Unity terrain and feed that into a shader, which interpolates between the new camo and a default texture. We'll also use a simple calculation to work out how well the camouflage is working and add a camo index to the UI. The completed project is available on GitHub, but there's a lot of moving parts to this one and a lot of setup before we get to the shader bits, so I'd really recommend watching along and trying this all out yourself and playing around with things as you go. For this project, we will start off with the universal render pipeline default scene, but I'll delete the floor because we're going to replace this with a Unity terrain. Make sure you select the URP template or install it using the package manager. We will also be using a couple of other packages, so go to Window, Package Manager, select all packages from the drop-down menu and search for the Terrain Tools package, then search for the Cinemachine package. The Terrain Tools package contains a few extra brushes and tools that make it easier to create terrains, and the Cinemachine package gives us easy to use and flexible camera control, although we will only be using this in a very basic way. The final thing we'll need is a character controller. I'm using the Robot Kyle character from the Asset Store, which I'll link in the description. It's an old and relatively low poly character, which makes it easy to edit in external software, and that's just what we're going to do. For the camo effect, I'm going to make it so that certain parts of the robot model remain uncamouflaged, but it's going to be tedious to do that using only one material on the model, because we would need to create some sort of mask texture to determine what gets camouflaged and what doesn't. Instead, I'm going to cheap out and add a second material slot. I opened the model in Blender and painstakingly selected each of the faces I wanted to apply the camo effect to and assigned them to a second material slot. This will allow us to open the model in Unity and add two materials to it. The first material will be used for the non-camo parts, and the second one will have a custom shader that we will write, which applies the camo to those parts of Robot Kyle. We will also add a few animations to the character while they're moving around. We want the character to have walking and crawling animations, plus transitions between those states. I'm no animator, and although Metal Gear Solid 4 was one of the most expensive games ever made back in 2008, we unfortunately don't inherit its budget by ripping it off. So instead, we're going to use Mixamo. Mixamo is a fantastic resource if you're looking for placeholder animations, since it's free and it essentially has any basic animation you could possibly need, alongside a few basic parameters you can play with. The site exports to a Unity-friendly FBX file, which is perfect for us. I downloaded animations for standing idle, prone idle, walking, crawling forward, stopping crawling, and standing up. I didn't actually find a satisfying animation for crouching back down, but I did a dirty hack and just played the standing up animation backwards. Game development is just a series of unstable hacks piled on each other. For this section of the video, I'm going to be showing you how to use the terrain system live. I am in the project after it's completed, and I already have a terrain to work with, but I'm just going to step through how to make a new terrain and how to modify the height map, so that is the kind of these hills on the terrain, and how to apply different textures to the terrain. So I'm going to come here and deactivate the existing terrain, and then I'm going to go to Game Object, 3D Object, Terrain. And that's going to create this new terrain asset down here, and also put a big old terrain in our scene. Now, to start off with, if you come to this cog menu here, this is the terrain settings, and we're going to want to turn the terrain width and length down a little bit. So it's currently 1000 by 1000, which is too much to work with. So I'm going to change this to 50 by 50, which I believe is the size of the terrain I had before. The terrain starts from the corner outwards like this, so I am also going to translate it by 25 on the X and the Z by setting those both to -25. Now, by default, the terrain is this grid texture, and we're going to want to add a dirt texture, which was what was in the center of our scene, and a moss texture, which was the remainder of the scene, or the remainder of the terrain rather. And to do that, we are going to come to this little button here called Paint Terrain. This gives us more than one option. So there are several, I guess, options here for modifying the terrain, and we want to select Paint Texture. We will be dealing with raising and lowering the terrain in a moment, but first of all, we're going to paint the texture. Now, you are given a lot of brushes to work with here, and these are basically, you know, as you can imagine, like any painting tool, you get these brushes. So we're just going to use a basic one for now. And to begin with, we are going to want to add in layers. Now, if you come down to the layers drop down here, a layer is basically a texture slot for the terrain. So if we come to add layer, if you downloaded the terrain tools package from the package manager earlier on, you will get these by default. So the first one we'll add is the moss one, and that's going to cover our entire terrain with whatever the first texture was. And because we want most of our terrain to be moss, we just want to have that as the first one. And side note, you'll notice that there's the selection outline on this terrain. If you come to the gizmos drop down here and untick selection outline, it will get rid of the orange tint around the whole terrain, and that will make it way easier to paint and see what colours are actually being painted on the terrain, or else you get this orange tint and it gets in the way. So this is all nice and fine, but we also need a second texture slot to actually modify the textures on this terrain. So if we come to add layer and add dirt as our second slot, to actually paint on the details on this terrain, first of all we'll look at these settings we have here. So these are all basic. The strength is basically how strongly it's going to be painting the terrain onto the surface, and brush size is how big this circle is, or if we use a different brush, how big that brush is. So we're going to stick to this circle for now. I'm going to set this to something like maybe 4. Yeah, and I'm going to set the brush strength to 1 for now. This is just going to paint at maximum strength the texture that we currently have selected. So we're just going to go around the outside like this and paint roughly this dirt pattern. However, I want the edges to be a bit softer, so I'm going to set this to 0.1 and then do a once over around the outside, and it's going to give us this much smoother look, this smoother transition between the dirt and the moss. The interesting thing about our camouflage mechanic is that when the robot Kyle wants to change its texture, its camouflage, it's going to pick the strongest texture from the terrain where he has stood. So on this boundary kind of here, it's going to pick the texture with the strongest amount of that texture. So on the boundary it'll be a bit more interesting. And Robot Kyle also pulls the texture on the terrain to calculate the camo index, which is how strongly he's being camouflaged. And that's also going to pull the textures on the terrain and figure out which is the strongest one at each point. There are other options here. So if we had a different brush, one that can be rotated, if you modify the brush rotation, you can just about see the star rotating on the screen there. But that's not actually relevant for just this brush, and I'm not entirely sure what the brush spacing does, but that's not important for us anyway. The second thing we're going to do is come to Paint Texture, this drop down, and go to Raise or Lower Terrain instead. And this is the tool that we use to modify the height map of the terrain. Now by default the brush strength is 0.001 I think, or I may have modified that myself. We are basically going to go around the outside and raise a little bit of a hill on the edge of the terrain. Now, this can be a little bit tedious, but it is a delicate process. So don't set really big strength values and just go, you know, if you did this, obviously that's an extreme example, but it obviously looks really, really stupid. The way you usually modify terrains is by setting really tiny values on brush strength and just kind of edging along, making little hills here and there, because if you go along and make massive hills, then it'll end up looking really, really silly. So just kind of nurse it, you know, just kind of go around the edge, try out a few of the different brushes. So once I'm gone around with the basic circly brush, I am going to go background with one of the more interesting brushes. Maybe this one or this one, which have a more noisy texture, and just go around again and maybe click a few times, maybe just add a little bit more detail. Nothing too much, because if you make these hills massive, then it will be really, really silly looking. If I come down to kind of eye level and survey around the area, I'm happy with what we've got. So I'm going to leave this section here and move on. And now it's time for a little intermission. These videos wouldn't be possible without the Patreon supporters on screen right now, as well as all my subscribers and everyone else who supports me. Watching my videos and subscribing is already a fantastic way to support me and the channel, but if you're looking to go the extra mile, there's a bunch of ways you can support me down in the description. I appreciate every comment people leave on my videos, and I try to answer your questions if I can. Right, let's get back to the shader. Now that we have a terrain to stand on with two textures on it, it's time to add the animator controller to Robot Kyle, piecing together the animations we grabbed from Mixamo earlier. I've done this behind the scenes because I don't want to put you through the pain of setting up each animation, but the basic gist is that each state transition will happen when we're moving the player or when we press the crouch button, except the transitions from the standing and crouching animations to the following animation. You can play around with these animations if you download the project, and I'm happy to answer your questions about this in the comment section. As a disclaimer though, this character controller ended up being extremely janky and jittery, and I do not recommend that you use this controller in any game of your own. And I firmly believe that every animator deserves to be paid twice as much as they are. This was pain. Next up, we need to add collisions to the scene geometry. By default, the objects in the URP scene don't all have colliders attached, so we're going to go through and add our own basic box colliders to all of these elements. This is just to make sure that our character doesn't phase through the geometry. And now we come to the player controller script. I've created two capsule colliders as child objects of the Robot Kyle character, one for a standing orientation and one for crawling. I've done this rather than rotating a single capsule because I found this a bit easier to work with. By default, the crawling collider is disabled and we're going to switch between them using a script. I won't go into full details about the player controller script. I originally had that as a section of this video, but it's already quite long. The only thing you really need to know is that we use animator.setBool and then pass in a string to reference which boolean on the animator we are modifying, and a boolean to signify how we are modifying it. Back in the Unity editor, we can apply that script to Robot Kyle. So if we highlight Robot Kyle and just drag the script onto him, then perfect. We're going to make the move speed 1.5 and we're going to attach the standing collider and the prone collider to Robot Kyle and save. Now if we were to play, our camera will remain stationary, but we can move the player around. So I am using the WASD keys. I can press space and Kyle will crouch down, and yet again, animators should be paid more. I hacked this together, it's not elegant, but it works, so we're going to move on. That is the Robot Kyle player controller finished. The next thing we are going to add is going to be basically a database that is going to store each of the textures used on the terrain alongside a colour for those textures. Before we do this, we are going to need to do one thing. If you come to the search bar here and search by, I think it's by type, search for all of the textures in your scene, and we're going to search for ones with albedo in the name. The problem with what we're about to do is that we actually need to make sure a flag is set on each of these textures. So if we were to just select all of them, just for now, we are going to need to make sure that a tag here called read/write enabled is set, because we are going to use a method called texture.getPixels, and it will not work if this is not ticked. So for especially any texture that you have on the terrain, I've just selected all of the albedo textures for now. All of the ones in the terrain tools package are called something underscore albedo, so it's easier to search from this way. You're gonna want to have to make sure this flag is set, or it won't work. With that out of the way, I'm going to undo that search, and we are going to create another script called Camo database. Now, the interesting thing about this script as opposed to the others we're writing is we're not going to make this a mono behavior. It's just going to be a regular Unity class. A regular non-Unity class, sorry. A regular C# class. So, again, get rid of the boilerplate. And we're basically going to set up a property, which is static, and it's publicly accessible, but not publicly assignable. So this is kind of some funky C#. I'm just going to roll with this. So we basically say private static camo database, and we're going to call this instance. And this is basically going to be a singleton. So we only want one camo database object to exist in the game, and this is going to be it. So it starts off as null, but we're going to say public static camo database instance with a capital I, and this is going to be some funky stuff. So we are going to make a getter and a setter. The getter is just going to check if the instance is null, and if it is, create one. And we're going to have a set method, or yeah, a setter, which can only be accessed by this script, and it will basically assign the camo database that is created the first time that this instance is requested by another script. It's going to automatically create it for us. So we're going to say get and open some curly braces, and in here we're going to say if instance is null. So if instance double equals null, we're going to say return new camo database, and then we're going to say return instance with a lowercase I. So if we don't have an instance, create a new one and return that, else return the one that we have. And we're going to say private set, open a curly brace, and we're going to say instance equals value. So this is some special syntax, which basically means whenever we try and set the value of this property, it's going to be passed it's this value keyword, and it's going to assign that to this backing data with a lowercase I instance, which is automatically created here. And this is the only place this constructor is called. So this is just some fancy tech, I guess. The other thing we're going to need in this class is a private dictionary, and this is going to contain texture 2Ds and colors. Now, this is the database of colors attached to each texture, and we're going to call this camo colors. That's going to be a new, we can just auto complete that, so that when this is created, it just automatically creates a new dictionary, rather than us having to create one in the constructor. In fact, we won't even write a constructor, just because that's the only thing that gets created. And this dictionary is going to contain a color for every texture, and we're going to use this to compare two textures and determine how similar they are. This is going to be used for the camo index. So the way that we do this is we're going to add a new method called public color get camo color, and we're going to pass in a texture. So it's going to be texture 2D texture, and we're basically going to say if the dictionary contains a key for this texture, then return the color value that it already has. Else we're going to calculate the color of this texture and add it to the database. So we're going to say if camo colors dot contains key texture, then we're going to return camo colors at texture. So this is like array access, it's super simple like that. Else we are going to do something here that adds it to the database. And for that, we're going to have another method. So it's going to be a public color, add camo color, and again, we'll pass in a texture 2D. Texture 2D texture. And just here, we're actually going to say, you know, return add camo color texture. So that's that method done. And in this one is where all the fancy stuff's going to happen. So first of all, we will say var pixels equals texture dot get pixels. Now this is going to get well, it's a massive array that contains every single color of every pixel of this texture. Bear in mind that this texture could be, you know, 1024 by 1024, so this is a very big array. It can be millions of values. But that's fine, because this method won't be called very often. We're going to say, well, basically we're going to go over every pixel, and we're going to take the average color. So we're going to say vector3 color, and there's a reason we're doing a vector3, don't worry, equals new vector3. We are going to convert this to a color in the end, but the way that colors work under the hood is a little bit tricky, so I'm going to make this a vector3 so that when we sum all of the color values, the intermediate color values of each pixel, it stores them all correctly. Because I'm actually not sure, if we did a color here and tried to add more than one, it might get a little bit funky, and we're trying to avoid that. So if we say for, so we're going to iterate over every single pixel, so for int I equals 0, I is less than pixels dot length plus plus I. Now I know that might irritate some people because you'll probably just put I plus plus, but I heard from someone that plus plus I is faster and I stuck with it since then. But basically we're going to say color.x, so that's this vector3. We're going to say color.x plus equals pixels dot, well, pixels at I dot r. So the x component of the vector3 will be the red color, and the same for the y is the g, and the z is going to be the b. So color dot y plus equals pixels at I dot g, and color dot z plus equals pixels at I dot b. So this is going to sum every single color value in the texture. And then we're going to say color divide equals, and this is something that you can't do with the color type. So we're going to say color divide equals pixels dot length. So that's how many pixels there are. We're basically now going to say var return color equals new color, and it's going to be color.x, color.y, color.z. No, it's actually at this point I'm realizing that I'm mixing the British and American spelling of color, just because, well, I'm British, so I want to use a U in the spelling, but I also want to cater for the American audience and the fact that the color type does not have a U in it. So sorry for mixing these up. I hope you can still follow. We're going to say camo colors, which is the database up here, this dictionary. Right, so I'm going to say camo colors dot add texture, that's the key, and return color is the value. So return color is just the average here, and it's converting back from this vector3 to an actual color object. Then we're going to return color. Perfect. The great thing about this script is because it is not a mono behavior, we don't have to attach this to anything. This script is done and it will just work. And that's because of the beauty of this singleton. Now we can move on to the third and final script we'll be writing today, and that is the Camo controller script. So right click again, go to create C# script and type in Camo controller. I love being able to spell, it's great. We double click that open. And this is going to also be attached to the player, but it's going to interact with the terrain that we've made. So yet again, delete everything in the template. And we're going to need a few things to begin with. So we'll need a public terrain. And there's no points for guessing which terrain we're going to attach here. This is just the one terrain that we have. We are going to need a reference to the material that the camouflage is using. So we're going to store this camo material. We are going to need a reference to a UI image and a UI text that we're going to be using to report the values of the camo index. We will create the UI in a second, but basically, before we do that, we're going to have to say using Unity engine.ui. This is going to import the namespace for the UI elements, and we're going to be able to say now public text camo index text and public image camo index image. These are just going to be reporting the difference in color between the camouflage that the player has and the texture on the terrain. Now we're going to need a few things that are private to this script. So first of all, private float camo index. And that can be 0 by default. As we've mentioned, this is a number that represents how well we're camouflaged. So this is essentially the difference between the colors that we set in Camo database for each of the textures in the game. Next, we are going to need a private texture 2D current camo. And this is just going to be null to begin with, and this is going to store what the texture we currently have is. The next thing we're going to need is a private float camo index update time, and this is going to store how long it's been since we last automatically updated the camo index. The problem with the terrain system that we have is that it's quite expensive to calculate where exactly we are on the terrain and pull the texture. So we're not going to do it every frame because that would tank the performance. We are instead going to do it every, say, half a second or 0.75 seconds. And that's going to make our game run a lot smoother. This is the time since we last did that. Then we're going to have a private coroutine. We're going to get fancy. And we're going to call this a set camo routine. And to begin with, this is null. So whenever we manually set the camouflage, and we're going to do that by left clicking, we are going to create a coroutine, and we'll get onto what those are in a second, that is going to modify the shader that we have attached, and it's going to lerp to the null, the default non-camo texture, and then it's going to lerp back to the new camo texture. And that's going to be done in a coroutine. Next up, we're going to need a few constants. So if we say private const float camo switch time, and we're going to make this 1.75. Now the camo switch time is going to be how long it takes for us to switch between each camouflage. So this is the time it takes for it to switch to the non-camo texture and then back again. We're also going to need a private const float camo threshold. That's going to be 0.5. When we are calculating what the most prominent texture on the terrain is, we are going to use this threshold to determine what the most prevalent texture is. So when we were painting on the texture, you'll remember we had some overlap areas. We're going to use this threshold to determine which texture is the most prominent. And finally, we'll have a private const float, and we're going to call this one camo index update threshold. And this is going to be, we'll make this 1 second. So this is going to be how long it takes between each update of the camo index. I'm going to leave it for 1 second for now, but we could make this higher or lower if the performance is bad or good. And finally, we are going to need a private player controller. And this is just going to be a reference to the player controller script, but this is on the same game object, so we can make it private and just use get component to access it, which we're going to do now. The first thing that we're going to add here is a private void, and this can either be start or awake, but we're going to make it start. And in here, we are going to add, before we do anything, we're going to add the current main texture applies to the camo material, to the camo database. And the reason we do this is that we always want to make sure that it's in the database so we can compare it. So if we say, and this is the magic bit basically, camo database dot instance, and this is going to, if this is the first time it's called, which it probably is, it's going to automatically create the instance for us. So instance dot get camo color, and well, actually this, no, sorry, it needs to be add camo color, and this is going to be, we're going to pass in the camo materials. So camo material, it's main texture. But the problem here is this returns texture, and we need to pass in a texture 2D, so we can cast like this. Because this is always going to be a texture 2D. It just doesn't, necessarily know that. But we know this will be a texture 2D, so we can cast to texture 2D using this cast. The second thing we'll do is get a reference to the player controller. So that's dead easy, just player controller get component player controller. Then we are going to handle user input. So basically all we're looking for here is the player input of pressing the left mouse button to automatically basically do the Octocamo mechanic, which is going to be read the texture on the floor and apply it to the player. And we're also going to check whether enough time has passed to automatically try and update the camo index. So we're going to say private void update. And the first thing we'll do is if input dot get, I think it's get button down, fire 1, which by default is the left mouse button, and I think the control key, but we're also going to make sure that we're not already setting a texture. So we're not already doing the interpolation process I mentioned, the lerping. And we can basically, we will check whether the set camo routine coroutine is null. We are going to be calling this later, so don't worry about this for now. But this is basically saying, if we're not already setting the camo, then we can set the camo. And if we just make some curly braces here, we are going to come back to this. So there are a couple of methods we need to write first. Then we're going to say else if, no, it's actually probably easier if I put a tab here actually and come back to that. Now for this script there are a few things we want to do in the update loop, but we're going to come back to that because we need to write the other functions first, or the other methods first rather. So I'm going to write private void update, but I'm going to leave it there for now. The first method that we are going to write is called getTerrainTexture. So this is going to be a private texture 2D, and it's going to be called getTerrainTexture. And this is going to read the terrain here, and it's going to figure out where the player is, and it's going to pull that little section of the terrain, that basically a pixel of the terrain, and it's going to calculate what the most prevalent texture on that area of the terrain is and return its texture. So this is going to be a little bit in depth, but I'll step through it as best I can. First of all, we're going to need a terrain data. So the terrain data is an object that contains data attached to this terrain. Pretty simple, does what it says on the tin. I'm going to call this tData, and it's going to be equal to terrain
terrain data. And we could, you know, type this out each time, but it's going to be much shorter to just write out t data, which is why we're caching the value here. Next, we're going to initialize a vector3 called position. So this position is going to be where on the terrain the player is. So to do this, it's a little bit in depth again. So we're going to say position.x equals, I'm going to open a couple of curly braces here, and we're going to say transform.position.x, and that's the location of the player. Remember that the Camo controller class, or this script, is going to be attached to the player. Minus terrain.transform.position.x. So we're going to subtract the terrain's world position, and outside of the brace here, we are going to divide by t data dot size dot x, and that's the size of the terrain. And then we're going to multiply by t data dot alpha map width. The alpha map is the texture which stores it stores the textures that are attached to the terrain, and it stores how the alpha map stores the strength of each texture attached to the terrain at each point on the terrain. So it is a texture in and of itself, but we need to multiply by how big that is after dividing how big the terrain is. And we're going to do all this process again for position.z. So I'm just going to copy that down. It's going to be position.z, and it's going to be transform.position.z, terrain.transform.position.z, and we're going to divide by t data.size.z, and we're going to times by alpha map height. Super simple stuff. Then we're going to initialize a texture ID as 0. And this is going to store, basically we're going to loop through every texture attached to the terrain and store what is the most prevalent texture so far. So by default, we'll just make it 0. Now we are going to need to get basically the alpha map data at this point on the terrain where the player is stood. So this is kind of some very annoying syntax, but it returns this as a 3-dimensional float. We'll see how to work with this very shortly. We're basically going to say float open square brace, and then we're going to put 2 commas, and that means this is a 3-dimensional array. We're going to call this alpha maps, and this is going to be t data dot get alpha maps, and we're going to pass in the int position dot x, int position dot z, and then we're going to pass in a 1 and a 1. Now what this is doing is it is going to this position, and it's going to get a value from the alpha map of this size, this width, and this height. So it's going into a texture essentially, and at this position and this position on the x and z axes, it's going to get a pixel that is 1 by 1. Now the reason this is 3-dimensional is that you can, well, basically you can get more than 1 pixel's worth. So the first 2 entries into this array are the x and z position on the terrain, and the third value is the ID of the texture. So if we have 2 textures applied and we're looking only at 1 single pixel, as we are here, I think I'll just click by something by accident. This array is going to be 1 on the x dimension, 1 on this dimension, the second entry, and it's going to have 2 entries on the third dimension. And that's okay for us. We are going to iterate through this this 3-dimensional floating point number array But we know that there is only going to be one entry for the first 2 dimensions. I know this is like a little bit weird to understand because of the way the alpha map is constructed, or at least the way that this method returns the alpha map, but just roll with it. I'm going to say int I equals 0, I is less than, and it's going to be alpha maps dot get length 2. And this is going to be the length of this 3rd dimension, which happens to be equal to how many textures are applied to the alpha map, to the terrain. Then we're going to say I, or we're going to say rather plus I. Ooh. Inside here, we're basically going to say if camo threshold, this is the threshold value I mentioned above, if that is less than alpha maps at 0, 0, I. Ooh. So as I mentioned, there is only one entry on the X and Z. Well, this is the X and... So as I mentioned, there is only one entry, because we're only polling 1 pixel. So if the ith texture is stronger than the threshold, then we'll set the texture ID to I. And that's saying this is the strongest texture we've seen so far. And then we can just say return. It's going to be tData.terrain layers. So these are the layers that we added ourselves earlier at texture ID dot diffuse texture. And that's this method complete, finally. We are then going to use this in a set camo method. So we're going to say private I enumerator set camo. And this is basically the loop where we are going to lerp to the non-camo texture and then lerp to the camo texture. The first thing we do in this method is grab the current texture that we are stood on. So if we say var camo texture equals get terrain texture, which is the method we just wrote. Then we're going to say if the camo texture is equal to camo material dot get texture. We're going to call this underscore camo texture. So basically we're saying here, if the texture we are stood on is equal to the texture already applied to the player, we are going to store that in a shader property called underscore camo texture. So we're saying if they're equal, we're just going to do something special here called yield break. Now, an I enumerator is not like a normal method. This is an enumerator. And rather than returning conventionally, we use a keyword called yield. And if we say yield break, it's basically like just saying return semicolon in a normal method. So when we do this, it's basically saying end the coroutine here, don't do anything else. If this is not the same texture as the one that is currently applied, we're going to say for float t equals 0, t is less than camo, I think it's camo switch time, t plus equals time.delta time. This is basically a for loop that is going to run over time up until camo switch time. So if you remember, camo switch time is the amount of time it's going to take to make this camouflage texture into the non-camo variant, and it's also later on going to be the amount of time it takes to go from the non-camo variant to the new camouflage. Inside here, we're going to say camo material dot set float, and this is going to be underscore camo amount. This is a shader property we are going to use to determine how much we are the camo texture versus the non-camo texture. So if this is 0, this is the uncamouflaged version of the robot, and if this is 1, we will be fully camouflaged. So we're going to set this to T divided by camo switch time. And this is basically going to mean that the camo amount goes from 1 to 0 over the time span of camo switch time. Ooh, hang on, sorry. 1 minus T over camo switch time. Yes, this is going to go from 1 to 0 over the time span of camo switch time. And then we're going to say yield return null. This is another special property that, or special property, a special command, a special instruction that basically says stop executing now and don't do anything special. What yield return null does is it basically says come back next frame. So then it's going to add on the delta time, the amount of time between frames, and continue execution of this loop. And then once it has executed the whole loop and camo switch time has been reached, we're going to add another line here called camo material.setFloat. That's going to be the camo amount. 0. The reason we do this is that this loop might execute without having set camo amount to 0. It might be very, very slightly above 0, and we don't want that. So this is just a small correction. Then we are going to say camo material.setTexture. It's going to be underscore camo texture. So the same one that we had here. And we are going to set this to camo texture. So basically, if the terrain camo texture, well, if the texture applied to the player and the texture applied to the terrain below the player are different, so if this was not true, we are going to assign that camo here. We are also going to say camo database dot get dot instance dot get camo color, and we are going to pass in the camo texture here. The reason why we don't use add camo color here is because I basically made this so that get camo color has side effects to it. So it's going to check if the key exists, and if it does, it will return that, and if it doesn't, it's going to add it. So that's just a small, I could write this same if statement down here for add camo color, but I was lazy when I wrote this code, so so be it. Then we are going to do the end part of this loop. So once it has set the camo texture, it's going to do the inverse process that we have here. So I'm just going to copy this whole thing. And we're going to say, for float t equals 0, t is less than camo switch time, t plus equals time at delta time, that can all be the same. The difference here is that we're going to get rid of the 1 minus. So this is going to go from 0 to 1. And then afterwards, we can set this to 1 rather than to 0. And at the end of all of this, we can say set camo routine equals null. So when this coroutine is about to exit, we'll set it back to null, and this means we will be able to, we're basically going to be able to check whether this coroutine is executing, so that if we are already transitioning our camouflage, we won't let the player try and transition their camouflage again, if that makes sense. The final method we are going to add here, right at the bottom, is going to be called private void update camo index. And you guessed it, this is the method that's going to update the little indicator in the corner to tell us how well we are camouflaged. So we're basically going to say terrain, so yeah, var terrain texture equals get terrain texture. So that's going to call this method and get the texture we are stood on. Then we're going to say var terrain color and I'm going to spell that in the American way this time, just so people don't get confused. I'm going to say camo database dot instance dot get camo color, and we're going to pass in the terrain texture. So terrain texture, the one that we just retrieved, and we're also going to say var camo color equals camo database dot instance dot get camo color, and we're going to pass in texture 2D camo material dot main texture. So this is going to retrieve the camouflage currently attached to the camo material. Then we're going to do a very simple process here, which is basically some trigonometry, where we're going to now we're going to calculate the camo index, and we're basically going to use trigonometry here. So we're going to say camo index equals 1 minus, and we're going to do a square root here. So we're basically going to square the difference between the R, G, and B colors, and then take the square root of their sum. So we're going to say mathf dot squirt, and we're going to say mathf dot pow terrain. So it's going to be terrain color dot R minus camo color dot R, and the second parameter to the power function is going to be 2, and then we're going to add that to basically the same thing for the G and the B. So I'm just going to Control C, Control V those. So I'm going to just say this one will be G and G, and this one will be B and B. This is a very long line, so I'll just put that over to the next line. And then we can semicolon that. And that is going to get the difference between the terrain color and the camo color. And we're going to do 1 minus, because if the terrain color and the camo color are the same, then the camo index is going to be 1. And if they are completely different, so if their distance, which is essentially what we're calculating here, is 1, then the camo index will be 0. So if, for example, we had black and white as our two colors, then they will have a camo index of 0. And if they are both white or both black, then they will have a camo index of 1, because they are the same color. From this, we can set the UI elements that we added to our scene. So we're going to say camo, it's going to be camo index text equals, we're going to say mathf.round to int, misspelled math, matah. So it's going to be mathf.rounds to int camo index times 100 plus the string that just has a % in it. So that's going to basically put the % on the screen as a string. Oh, sorry, it's going to be camo index text dot text. And then we're going to say camo index image dot color equals new color, and it's going to be white, so it's going to be 1 1 1, and then it's going to be 1 minus camo index. So this is going to be a little image indicator that when we are fully camouflaged, it's going to make the opacity 0. So this is the alpha channel here. The opacity will be 0 when the camo index is maximal, and it's going to be 1, so it's going to be very visible as an indicator when the camo index is low. Then we're going to say camo index update time is set back to 0. The final thing we have to do here is deal with the update loop. So there's only 2 things we really need to do here. The first thing is to poll the update. So we're going to say if, and in here we're going to say input.get button down, and this is going to be the fire 1 button. This by default it's either the left mouse button or I think the control key. So either, well, sorry, if the player has pressed the left mouse button and the set camo routine is not operating, that's why we set it to null after finishing. So if we press left and we're not already modifying the camouflage, we are going to say set camo routine equals start coroutine set camo. And that's going to make this coroutine start. And then we're going to update the camo index. So update camo index. Else, if, basically this is going to say, you know, if we have elapsed enough time since last update in the camo index, we're going to say camo index update time is greater than camo index update threshold, and the player is moving. So that's why we added that extra method on player controller. We do not want to poll for a camo index update if we're not moving, because there's no point. The terrain is not going to change at runtime, and the only reason our camo index will actually change is that the player has moved into a different area, rather than somehow, I don't know, grass grows very quickly over the dirt. Although, you know, if you wanted that as a game mechanic, then you can modify this as you wish. That would be quite cool. Then we're going to say update camo index inside here, and that's all we'll do. Then at the end, we're going to say camo index update time plus equals time.delta time. So this is going to count the timer up until we exceed the threshold. Then it's going to automatically update the camo index and reset the camo index time back to 0. And that's it for the camo controller script, which is quite a long one. I appreciate this might be a little bit tricky for people who are just starting scripting to get used to some of these concepts. So if you have questions about this, please do ask them in the comments. I would be especially surprised if no one asks kind of for more information on what these coroutines are, because they are super helpful. And if you're kind of confused about what they're doing, then I will answer any and all questions that you have if I can. So we're back in the editor, and we are going to go to the robot Kyle, and we're going to find the camo controller script and drag that onto Kyle. Now we can drag the terrain, the camo material, which is this one here, the camo index text, and the camo index image, which I already added to the scene. So if I go into 2D mode and I zoom out of the canvas, I just added a very, very basic an icon here that I created myself, and an index here, and a text here, which is for the camo index. So these are all both super simple to add. And on the robot Kyle, we're going to drag them both on. So the image goes here and the text goes here. Now if I just zoom back into the scene. Great. That is everything set up now. All we need to make now is the shader, which we have actually avoided until now. Inside the project view, if we right click and go to create shader, go to PBR graph, and we're going to call this Octocamo. If we open this up, and I'm going to pop this out so you can get a better view. Just drag this out like that. So this is actually going to be an extremely basic shader. Like, you will be surprised at how easy this is. We are going to need a texture 2D property called main texture, and we're going to give it a reference. Now this one is very important, underscore main texture with a capital M and a capital T. So when we were in the script and we said things like, if we find it, when we said camo material.main texture, that automatically refers to this reference. So it's very important you get this right. And we're going to need another texture, and we're going to call this camo texture. And we're going to give this a reference of underscore camo texture. This is the same property reference value that we used here. So just make sure it's the same as the one you use in the script. You can name it something different, but this is the name that made most sense to me. and we are going to need a third property of type vector 1, and this is going to be called camo amount, and it's going to be called underscore camo amount. Now we can actually go into the mode here and make this a slider between 0 and 1, but we will only be setting this in scripts. So this is useful for testing because we will only ever want it to be between 0 and 1, so that's just going to make it a pretty little slider if you want to manually test out how this shader interpolates between the main texture and the camo texture. Now we need to actually sample both these textures. So if we drag out the main texture and then drag out a sample texture 2D node, super simple stuff. And then we're going to also do the same for the camo texture. So drag that out and say sample texture 2D. And then we're going to go for the RGBA outputs, and we're going to say lerp. And we're going to attach the main texture into the A node, or the A pin rather, and the camo textures, RGBA, into the B pin, and take the camo amount and put that into the T pin. And then output that to the albedo. And that is the shader done. That is all we need for this shader. If you so wish, you can also add a normal map, because a lot of the robot Carl comes with a normal map by default, but you know, I'm going to avoid that in this tutorial. In the project it's in there, but this is easy enough, I guess. If you go to save asset, and then we can close this window down. Now I was very sneaky, I actually prepared this earlier. If we select the robot camo material I already have this Octocamo shader attached. I had one with a normal map, but basically if you just make the the main texture this robot default texture, and the camo texture can be whatever you want it to be by default. If we were to play the game now, because we already attached this material to the camo controller script, everything should work. And I'm actually going to separate the game view out here and rotate the scene view so we can just see the robot a little bit better. If we were to edge the character out to this mossy area and press left click, we will see that the shader automatically, well not automatically because we left clicked, but it's going to lerp out to the default texture and lerp in to the new camo texture. Same if we were to go back onto the dirt, left click, and it's going to lerp out and lerp into the dirt texture. Now if I left click again, you should be able to hear that. It does not lerp, and that's because our camo texture that we have applied is the same as the terrain texture, and we didn't allow it to change if we did that. The last thing we're going to do in this tutorial is to use Cinemachine to control the camera. So basically Cinemachine is an automated camera control system where you can add volumes, new transitions, and loads of fancy things like that, but we're going to use the very bare basics. It's easier than writing our own controller. So if we select the main camera in the hierarchy, and we come to add component and add a, sorry I already started typing there, so if I say Cinemachine brain, the brain is basically going to say we want this to be the camera that's going to be controlled by the Cinemachine system. Then if we go to our cameras object here, that's just an empty game object that I've made the parent of the main camera, and I'm going to right click and go to Cinemachine and select virtual camera. Now the virtual camera is going to be what it says on the tin. It's a virtual camera that our main camera will follow around. So I make this a child object of this cameras object, and we're basically going to drag on Robot Carl onto the follow and onto the look at fields here. So you can see it's updated on the game view. Our camera is now following and looking at Robot Carl. So by follow I mean that the camera will translate when Robot Carl does, and look at means it will face Robot Carl. We can modify how it is going to follow and look at. So in the body section, so I've already dropped this down, but you may have to click this little triangle button, we are going to modify the follow offset to something like -5. Ooh. minus 5. So it's going to be a little bit further behind, and we're going to say something along the lines of y is maybe 2, so it's going to follow from slightly higher up. And the tracked object offset is going to be y is going to be equal to 1. And you can see on the update here, this little yellow dot is the center of the screen. And by changing that, it's just changing the part of the tracked object that we're aiming at. Because the pivot of Robot Carl is down at his feet, we want to add an offset of 1. And that means that it will look at his torso, or not his torso, his pelvis. Just so we're not looking at his feet, because that looks a little bit weird. Now if we play the game, and if we move about, it's going to automatically follow Robot Carl around, which is exactly what we want. So if we select off the virtual camera to remove these little borders, and we go on the play mode again. In fact, if we were to go to maximize on play, we move Carl around, when we left click here, it's going to automatically change his camouflage. Might be a little bit hard to see because for whatever reason I decided not to make his back section camouflageable. But yeah. And that's the very basics of Cinemachine. And with that, the Octocamo effect is complete. The shader for this project was surprisingly simple, and most of the complexity of this project was in writing scripts that interact with the shader and to read data from the terrain. The whole point of this video was to show you just how shaders are one part of a big puzzle, and if you want to make the most out of them, you'll have to find ways of integrating them with other systems in Unity, especially scripting. I appreciate that this tutorial was heavy on the coding side, but if enough people request it, I'd be very interested in revisiting this in Bolt, Unity's visual scripting system. The next video after this won't actually be related to game development. Instead, I'm going to be dipping my toe into a Minecraft series. I've had this planned since I started my channel, but rest assured, if you're only here for the game dev content, I'm still going to be making high quality tutorials about all kinds of shaders. The video following this Minecraft one will be all about portals. I've written extensively about them on my website in the past, but I'm planning on bundling the entire thing into a single video, and I'm going to be converting it to URP and cleaning up the code, so expect it to be the longest Unity video to date by far. And after that, I'm going to start work on a series of general beginner Unity content and extend my written Unity tips series into a video format. I can't wait to see where this channel goes in the new year, and from this point on, I'm hoping to get content out faster than ever. Thank you so much for watching, and I'll see you next time.